we're going to perform translations and dilations on function f of x, which is this function right here. That function is the square root of 9 minus x squared. And then we are going to perform those functions to get this function g of x. And that function, g of x, has f of x in it, right? So g of x has actually been written as a function of f of x. Let's talk about what's happened to f of x to get g of x. So the first thing I notice is this outside transformation, this 1/2 right here. Okay, that is an outside transformation. And it is a vertical dilation by 1/2, or a vertical shrink. Okay, and that is like normally what we think of as A, or in the past what we've thought of as A. Okay, I also have this inside transformation happening. And we usually think of that as our H. So that is an inside horizontal transformation, right? So it's an inside transformation. We are going to shift this thing horizontally. Which way? Well, let's see. H here is -3, right? In order for this to be x plus 3, it's got to be a -3. So we're going to shift it left 3. We're going to go ahead and answer A here. Write the equation for g of x in terms of x. We no longer want f of x in there. We're going to actually take f of x and plug in the exact function wherever we see f of x. And we're going to do all these transformations to f of x. All right, so for A, g of x will equal, well, the outside transformations are always easy. They don't really affect the function at all. So I'm just going to write 1/2. Then I'm going to do the square root. And I'm going to go 9 minus. And as soon as I start thinking about writing something next to this input, in other words, my inside transformation, okay, I need that inside transformation happening to my input, to my x. So now I'm going to have a set of parentheses, and I'm going to say, well, this is x plus 3, and that whole quantity gets squared. So now g of x is written in terms of x instead of in terms of f of x. All right, now B asks us to plot both graphs on the same screen. And we're going to do that in a second in our graphing calculator. But first, I'd like us to think about what this graph maybe looks like. So let's first think about, how do I get my zeros here? What are some numbers that I can plug in for x to make this equal 0? That's right. If you plug 3 in for x, you square 3, you're going to get 9 minus 9, which is 0, and the square root of 0 is 0. What's another x value I can plug in to get 0? Good. -3. You plug -3 in, you square it, you're going to get a positive 9. 9 minus 9 is 0, square root of 0 is 0. So I know that those are my zeros. Now let's talk about my y-intercept. So if I plug 0 in for x, what do I get? Well, 9 minus 0 is 9. Take the square root of that, you get 3. I just got 3 great points on this graph. Knowing that I can't take square roots of negative numbers is going to be really helpful here, right? Because if I put in any x's that are too big in either direction, positive or negative, I'll have some imaginary numbers. So that's not going to work out. So our zeros are just going to be 3 and -3. I'm not going to get any negative outputs out. So again, I plug in 3. I get 0. I plug in -3. I get 0. I plug in 0. I get 3. It's actually a curve. Looks like that. No negative outputs. All right, now let's talk about g of x. So for any of these 3 points that I already have, I am going to shrink the output by a half. Okay, I'm gonna vertically dilate it by a half. So however tall it is, it's gonna be half as tall. And then I'm also gonna need to shift it left 3 units. So let's take my highest point. My highest point occurs at 0, 3. So that means that half of that, right, that vertical shrink, is going to end up going down to 1.5. But it's not just going to stay at 0, 1.5. I've got to now shift that left 3. So that point now moves over to -3, 1.5. Now the other 2 points, my zeros, are pretty easy to deal with. 3, 0, well, that output is 0. And if I dilate that by a half vertically, it's not going to change. 0 times a half is still 0. So that 3, 0 just needs to get moved over 3 units to the left. I'm going to do the same thing with -3. Again, that output is 0. Taking half of 0 is still just 0. So just move that over to the left 3 units. -6. And so now I've got a similar graph that's now half as tall and shifted left 3. Double checking this on my graphing calculator, I made f of x y1, I made g of x y2, and when I graph this, I can see that they match. I've also checked for my max, just to double check that it should happen at -3, 1.5, and it in fact does. All right, the last part of this, I think we've already done. We're going to describe how f of x was transformed to get g of x. I think we already did that. And you needed to include whether the transformation was inside or outside. Well, I've already said that. So this part right here is C. All right, another translations and dilations problem, page 22, number 20. This figure of this graph below shows the graph of the pre-image function f. And to the right, we have g of x, which is a function that's performed transformations on f of x. Let's identify those transformations first. I see this 4, and that's like my k. It's an outside transformation. I see that k is 4. This is an outside transformation. And it is a vertical shift up by 4. I also see this 1/2. And we were using B or D in our notes. So how about I'll say D. D is equal to 1/2. Now that is an inside transformation. And these are a little bit more tricky. So this is actually a horizontal dilation by the reciprocal of 1/2. So this is a horizontal stretch by the reciprocal of 1/2, which is by 2. So these two transformations together tell me that the function f here is going to be twice as wide, and it's going to be shift up 4. All right, so let's try and sketch the graph of g on this copy. Now, in order to help me do that, I am going to make myself some tables. This is one way to think of it. You can also say, hey, Frisk, I know what I'm doing. I can just go ahead and make the graph, and that's awesome. So I'm going to start with my endpoints. So that would be 4, 0. And let's talk about what happens to those endpoints when we create our new function, g of x. And I'll use a different. So how about over here, I'll do x, g of x. So I put in that input 4, and I get out 0. But now that input of 4 has been doubled. It's been stretched horizontally. So the new input for g of x will be 8. That should have that same output as f of x, 0. However, we need to shift g of x 4 units up. Sorry, we need to shift f of x 4 units up to get g of x. So instead of having an output of 0, we'll have an output of 4. All right, another endpoint here, or another 0, was negative 4, comma 0. And I'm just choosing easy points. Well, if I stretch that input of negative 4 by a factor of 2, I'm going to end up with negative 8. Now at negative 8, you might say to yourself, all right, then I'd have an output of 0. Except for that we are performing that vertical translation up 4 units, so you'd really have an output of 4. Let's use our point of inflection, or our last 0. 0, 0. Well, what happens when I stretch my input of 0 by 2, or multiply it by 2? Well, I still get 0. So the only thing that has to happen here is I'm going to now move up my y value to get g of x by 4. So 0, 4. The last 2 points I'm going to choose are my critical points. So at negative 2, I have a minimum. And at positive 2, I have a maximum. All right, so let's see what happens to these. So at negative 2, I stretch that input horizontally times 2. I end up getting, sorry, I should not have written that. I end up getting negative 4. I then say to myself, okay, well, instead of having that output of negative 2, I know that I need to shift it up 4, so that gives me an output of 2. All right, taking my last critical point, 2, comma 2, think about the input. That x value gets stretched by 2, so it becomes 4. But instead of having an output of 2, I need to shift it up, and I'm going to shift it up 4 units, so I end up at 6. All right, so let's graph these points. And you can also think to yourself, hey, let me take that, let's see, I'll start at the very far right. Let me take that point 4, comma 0, let me double it so that it becomes 8, and then let me shift it up 4 so that I end up with the point 8, 4. Negative 8, 4, same thing. So I'm going to start with my original point, which was negative 4, comma 0. So on the far right, or on the far left here. And I'm going to stretch it times 2, and then raise it up 4 units. So I end up at negative 8, 4. Okay, 0, comma 0 becomes 0, comma 4, because it can't be stretched at all, but it can be raised up. And then my critical points, negative 2, comma negative 2. Well, I have to double that, so the input now becomes negative 4, and I need to raise that up 4 units, so the output now becomes positive 2. And my maximum over there, that 2, comma 2, I need to double the input, so it ends up being at 4, and then I need to raise it up 4, so that ends up being at 6. Should look something like that. Now I've already identified, now that looks pretty terrible, but pretend like I did a good job with that. I've already identified the transformations, so B we did over here. And this was A.